correct. So let's put the equation in. All right, got the graph in there. Now, to test, first of all, you wouldn't really have to graph this one because we know that all parabolas are continuous and differentiable. There's no cusp anywhere on a parabola. But I like to go ahead and do that since it's on the calculator part of the test, because then the other piece of the hypothesis there is that your y values are the same at your endpoints. So if I go to trace and type in -3, I get 0. And if I type in 5, I get 0. So looking at the full part of Rolle's theorem, now we went through on some of your homework and actually found these values. There's your 5, and right there where it hits, that's your -3. Okay, so it passes the whole thing because we know we have a horizontal line. So now we just say f prime of c equals 0 because we want our tangent line, and it actually, guys, is going to occur at our minimum on this graph, isn't it? Because that's the only other place we'd have a tangent line with a slope of 0. But we can real quickly solve this and double check it by calculating a minimum on our calculator. If we take the derivative of f of x, f prime of x is what? What's the derivative? 2x minus 2, so now I just plug c in there so that I'm finding c. And what is c equal to? 1. We would divide both sides by 2. And if you wanted to check that, you could go back into your calculator and calculate a minimum, and it should give you that 1. So Rolle's theorem is usually a little quicker to do, just because it's equal to 0 instead of having to maybe possibly cross multiply. Okay? Questions on that one? Yes, Adam? Yes. That's this piece right here where basically you either show me a graph and say that it's continuous. Is everybody listening to this? Because this verification's a little bit more continuous and differentiable. And you could say f of -3 equals f of 5 equals 0, because that's another piece of the hypothesis. You don't actually have to show me the graph there if you don't want to, as long as you show me that you know it's continuous and differentiable and that the endpoints have the same answer for the y's. Okay? Any other questions there? All right. These last two, you tell me if you need them or not. I've got antiderivative here. Integral would be something else we could call that. The first one requires u sub. Could we use u sub on the second one? Okay, what's the derivative of 7x minus 1? 7. Am I okay there? Couldn't I pull my 7 to the other side? So I could actually use u sub on the second one. Now if that were 7x squared, I couldn't use it. I'd have to use probably Pascal's triangle and multiply that whole thing out. But I don't think I do that to you on the test with one that's cubed. I think you have one like that maybe that's squared, where you don't use u sub. And all of that stuff will be on the no calculator part of the test. Just so you know. Do we need to do those? Do you need to see the u sub? If I maybe just get you set up on it, would you be okay with it? What would you use for u on part A? The borrowing ones? Yeah. The one where you have to FOIL would be something like this. If I did x squared plus 3 squared, that one would have to be FOILed out. because if I take the derivative, if I try to use u as x squared plus 3, the derivative of that is 2x, and I don't have an x on the outside of it. I just have dx. So I would have to FOIL that one out. This one is a borrowing one, because if I do u as the secant of 3x, the du, yes, is going to be 3 secant 3x tangent 3x. Right, when we rewrite it, I'll pull my 3 over, and it becomes u to the 6th instead of u to the 7th. Right, when we raise it a power, we'll get it back to secant to the 7th again. But that would be u to the 6th du. The other secant is in the derivative. And do you guys know what to do from there? It'll end up being over 21, because we'll have 1/3 u to the 7th over 7. This one requires your plus c, so don't forget those. So I have secant of 3x. Now it's to the 7th, and you can either put it over 21 or you can put 1 over 21 outside, plus c. Don't forget your plus c's on these, because these are actually called indefinite integrals. Maybe that may be more what I'm looking for on what else could we call this. Do I need to do this one? That would become u cubed. I can maybe do that later if you need it, and I'll post it to the web, because I don't want to run out again on this one. This one right here, d, you would have to FOIL. I'm trying to run through so you have time, because I need to get your worksheets to you. This one would be no u sub. You just go straight integration. This, the u would equal 5x, and you could go from there. Because remember that I'm going to require you to use u sub on everything except parts like c and d. Now, do you remember how to do Riemanns? Riemann sums. Let me flip here real quick. Riemann sums, you got to do your delta x. 6 minus 0 divided by 5 is 1.2. And some of you, I know, draw your little interval things here. If you just get the first section down, you should have enough, because after that you can add 1.2s to get your other numbers. So if I want a midpoint sum, what's in the middle of 0 to 1.2? What's the midpoint? 0.6. So I would just, now you can still use your Riemann program there. You're going to do 1.2, and then you do f of 0.6, and just keep adding 1.2s. So 1.2 plus 0.6 is 0.8, and you end up with 5 numbers in here.